Welcome to the Atlanta Region meeting of the Georgia Occupational Therapy Association from February 13th, 2020, 7:30 to 8:30 p.m. This meeting originally took place at the Shepherd Center and remotely via Zoom. The topic? Makers Making Change in 3D Printing with Kristen Webber.
Properly. Okay, so Makers Making Changes out of Canada. These are all of the chapters in both the US and Canada. Atlanta is officially one. We don't actually have a star, but we did make a bullet point, which is very exciting. So let's make sure that we hit all of it. So the big thing is that this is a Craig Nielsen Foundation group along with Neil Squire and Google, and so those are the collaborating individuals for this project. As we know, assistive technology is incredibly expensive, and we find that 80% of people with a disability need an assistive device in their lifetime. And the more high-tech the device is, the more expensive it is compared to the cost of production. So some devices are actually estimated to be anywhere from 300 to 500% markup from the actual production cost. So some of the switches that we'll go over today, that I actually, if you guys wanted to take a peek at this and pass around, actually I don't have the photo on that one, but they are over $100 for just a basic button switch, and we can actually make those for around $15 to $75 depending on the complexity of that type of switch. So a Canadian survey on disability in 2012 showed that over, like we said, 80% of people with disabilities actually need some type of assistive aid to accomplish any part of their ADLs. Assistive technologies can come in many forms, which include apps, communication holders, low-tech and high-tech, and then it can obviously be ambulatory communication aids, you name it. And then really the largest need is in some of those high-tech switches, which we'll go over today. And the Joust is kind of the original device that the Neil Squire group and some of their research came up with, and that is the device that the cursor is over right here.
It's called a Joust.
Mm-hmm.
J-O-U-S-E.
Yep.
Joust.
You got it.
Mm-hmm.
So many people use and need assistive technologies for various reasons. Some people receive money to help pay for assistive technology through their health insurance. So as we know, the type of insurance that you have really indicates the type of access you'll get. So people that tend to have worker comp injuries have a lot of coverage. Kids that tend to be in school, they'll have access through their schooling. But what happens to these people when they drop out of those systems or when they lose coverage from their insurance? As we know, we end up having to focus on the necessities, and things like assistive technology really get left out. Over time, that can really lead to isolation for individuals with disabilities or anyone needing that type of access. So this is a photo of the research and development team, or one of the team members from Neil Squire, and she's actually using their lab up in Canada to start making some of the parts for, this one is the LipSync that she's got down here. Yes, you do. Oh, that is probably one I should have, okay, when we were brainstorming earlier. But yeah, Makers Making Change is run by the Research and Development Department of Neil Squire Society, a Canadian national not-for-profit organization that uses technology, knowledge, and passion to empower people with disabilities. The main focus of the Research and Development Department is to create and utilize newly emerging technologies that can enable persons with disabilities to promote their inclusion in mainstream society. So this is kind of what we were kind of casually talking about before the meeting started. Makers Making Change is really honing in on three big movements that's occurring. The first one being the maker movement. So that's the idea that we can all get a 3D printer and we can theoretically print our own baby Yodas or our own whatever trinkets we want, right? And that's really also goes into crowdsourcing. So who here has used Wikipedia? Right? And anybody has used like Airbnb or any of these companies, and those companies really focus on crowdsourcing. So we take mass knowledge and we put that toward acquiring something. Another crowdsourcing example would be Kickstarter. In this presentation and in the next one, we'll talk about Thingiverse and some of the crowdsourcing platforms that are actually specific to 3D printing. The final movement is open source. So there are certain products and groups on the market that they have what we call a closed system. So anyone that uses Apple devices, that's a great example of a closed system. Mm-hmm. Apple and Steve Jobs really cared about having crafted your experience with a device. So they limit the number of ports, they limit the type of apps you can get, things of that nature. When you start looking at other types of products like Linux or other types of operating systems, those are more open access. So that's like the Samsung phones or anything that's Android. The bar for producing an app and access is much lower. So the idea is that anyone can really get it and it's free. So for example, when I produce videos for the YouTube site, those are done through an open source editing software, which is why sometimes the videos have wildly different quality, but depending on what type of thing I was trying to find and download. So poor Kelsey has tried to convert many of my files back to things that she can access. All right. Do you guys have any questions about those? Okay. So next, let's talk about the maker movement. So we talked about this a little bit before, and the maker movement is a social movement that started as a reaction to overseas production and devaluing of goods. So I did not know this, and Makers Making Change definitely enlightened me. So nowadays, for example, if your toaster breaks, most people replace it instead of fixing it. This is because toasters have become so inexpensive with mass production, it hardly seems worth the effort to actually go and figure out how the toaster works and fix it. This is a very different attitude than our grandparents had 50 years ago, where the cost of goods was much higher, and if something broke, we really fixed it. So this has really contributed to kind of a throwing away culture. And as this was occurring, people started to kind of fight that movement, and that's where this maker movement started. So it started about the mid-2000s as a positive way to address issues that we're seeing in terms of like that toss away culture. So it was really meaning to be a powerful act and a way to make friends and learn from one another and change our cultural values. And this is actually a maker movement fair, and then some people engaging in maker movements, and then one of the 3D printer types that we'll review later. Okay. So producing instead of consuming. With the maker movement came the invention of the do-it-yourself 3D printers, Raspberry Pi computers, Arduino, I'm pronouncing that wrong, thank you, microcontrollers. So these are all things that you can program yourself to do what you want and then actually implement them. We're not going to get into the controllers and the programming because that's a much larger topic, but we can at a different time. Places called maker spaces started popping up all over the US and in Canada, where clubs of people could meet and come together to collectively buy and share inexpensive equipment like laser cutters, CNC machines, 3D printers, you name it. These accessible low-cost technologies and the sharing of this expensive equipment advanced the use and the open source of things. So in the Atlanta area, we have a lot of these maker spaces. So Free Space Atlanta is the largest one in our area, but then Decatur Makers is also another one. And all of them open up classes to the public and tend to focus on using open source items like the ones that we reviewed earlier.
Is that, we have one in Roswell.
There's a ton,
Oh,
yeah.
there are? Okay,
Mhm.
but so they're all kind of the same concept.
Yep.
There's not like one that's just for, they're all just spaces that you can make.
There are. Some of them they do require that. Like Georgia Tech actually has a maker space that's really great, but they require you to be like a university student, and they don't allow for storage of items, which can be hard if you're using the woodworking equipment, because then you have to like theoretically haul it back to your dorm or wherever you live near campus. Whereas other ones will let you, through donation or other things, have storage and stuff. So they all kind of have a little different focus too. Like Free Space Atlanta is really great for cosplayers. Decatur Makers is very family-based and community-based, so they do a lot of printing for the community, hosting Girl Scouts, doing that kind of thing. So in the past, typically only large manufacturing companies had access to this specialized equipment, but now all of those companies that we just listed do. So here's a great list that Makers Making Change put together of open source versus closed items. So on the left, we have open source software types. On the right, we have the closed and proprietary software. So depending on your comfort, one of the things my brothers told me when I was younger, and I didn't really appreciate it until I was much poorer and in college, was you should never be paying for something on the internet because you can always get it for free. I was skeptic that my brothers were stealing things, but they are pretty much correct on most accounts because there is going to be an open access version of it. It's just whether or not you feel comfortable enough manipulating the software that way or whatever the product is. Do you guys have any questions or comments? Okay. Cruising right along. Okay, so what's the crowdsourcing movement? So we touched on this a little bit before, right? Wikipedia, Airbnb, some different types of recording glasses, and the different robots. So crowdsourcing combines the idea of crowd and outsourcing, which was coined in 2005. It's not a new idea. Crowd meaning gathering ideas from wisdom of the masses, and outsourcing meaning to let others do something for you. Crowdsourcing and crowdfunding are a bit different, but they work on the same concept. So Kickstarter is a great example of a crowdfunder, right? And the other types of crowdsourcing information would be Wikipedia. So in, what was it called, Tipping Point, Malcolm Gladwell talks a lot about how if somebody was going to bet on the typical Britannica encyclopedia in the 90s versus one that was open access that anyone could edit. Which one is going to like put the other one out of business? I don't think anyone would have bet Wikipedia would, but it just talks about the passion that you can tap into. I think GOTA is a good example of that, and some of the volunteer work, the people that came to the Capitol Day. I mean, once you get kind of a movement going, it's easy to have the momentum keep moving. And so those are all companies that are examples of that. All right, so now we're getting into the assistive technology. Moving right along. Makers Making Change incorporates ideas of open source and crowdsourcing to create assistive technology designs. On the Makers Making Change website, there's open source assistive device library. And in there, you can actually go and you can print anything and link to any of the prints that they have and actually choose to print it in whatever type of format you'd like. On their site, you can actually go to the open source library as a maker or an individual with a disability and help review the product and suggest changes to it, or different types of products that they could, parlay together or adapt one another. So the idea is really that all of these individuals are working together to impact the assistive technology and make it more appropriate for the individual. So you have the maker, the healthcare professional, which is represented in the top circle, the maker, which is the one on the side, and the bottom, that is the maker fair that's occurring to help the person with a disability. So it's supposed to be everybody's gaining from one another. Okay, so I brought examples of these LowTech Solutions. So these were all 3D printed here by one of our employees, John McDonald. I was making small talk about how I got approval for this project. I'm so excited, and I got to find out now to go ahead and how to 3D print them when I don't have a printer. And I just sit at lunch and talk about work, and I show up at lunch the next day and he's printed all 3 of these devices for me. Oh. I know, what a doll. Yeah, he's just the sweetest. We're in book club together. So he printed all of these devices on a printer type that we'll talk about later, and these are also all part of the LowTech bundle that Makers Making Change has on their website. So I'll pass these around. This one is represented by the blue. I just don't have the nail clipper in it. So that's what this orange one is. And then we've got a bottle opener, and then if there was a key in this, it'd be held in place with the little screw and a nut. So nail clipper. And then really make sure to feel the edges on this, and we'll talk about the printing methods later. They're clever designs, right? So all of these items, like we mentioned, are part of the open source assistive technology library that's on Makers Making Change website and can be downloaded and 3D printed. When John McDonald printed these, does anyone want to take a guess at how long it took him to print them? So he printed all of them at once. A couple days, right? And there are a lot of different things that impact the duration of printing, but so it took him 11 and a half hours to print all of those at one time on one bed. But so when people talk about rapid prototyping, kind of keep those things in mind. Okay. Crowdsourcing assistive technology. Makers Making Change also uses crowdsourcing as a way to print and distribute their devices instead of using traditional methods of manufacturing. By getting people in the community involved in helping and supporting one another, the cost of assistive technology is significantly reduced. And since the costs of mass production and distribution are not necessary in this case. Another event that Makers Making Change hosts is called LipSync Build-a-thon. The LipSync, pictured on the right, is an open source version of the mouth-controlled mouse. Thank you, Adina. So she has some here because she's worked with Makers Making Change and incredibly recently too at one of the conferences. The device was designed by Makers Making Change team to allow people who are quadriplegic and can't use their hands to gain access to smartphones and tablets. The LipSync allows the user to puff into a straw on the left, click or sip to the right as they watch movies, call their friends, turn on their lights, or use other devices wirelessly and independently. So Makers Making Change hosts events where employers of large corporations, schools, communities, Girl Scout groups, can actually produce the LipSync and then help give it to individuals with a disability. This event not only helps the person with a disability access assistive technology that they may not have access to or be able to afford, but the event also serves as a team building exercise for those employers or for that company. It allows people to troubleshoot and create electronic projects, often for the first time in their lives. It can be extremely rewarding experience for both the makers, who think at the start of their day, I simply cannot do that, and then by the end of their day are confident in their independence with creating things like the LipSync. Because it certainly looks deep beyond a typical person's capacity, right, when you look at that, but they take you through step by step. So we alluded to this earlier. There are 3 primary people that can use the Makers Making Change website. And so you could literally log on right now from your phone and sign up as a disability professional. And then if you do have a 3D printer, you could also assign yourself a maker category. And then if you're somebody, a person with a disability or acting in lieu of one, like helping one of your clients, you can create a profile as a person with a disability and request builds. So this is taking you through the sign-up process. How you actually fill in and join the community. You select your role, your interests, your skills, and you complete the profile. This is an example of the different projects. There are lots and lots of projects. They'll link you to Thingiverse and other types of websites where you can actually get the CADs. And this is one that Adina as well has used here as well, this is the game stick. So this is specifically for gamers and can interface with the Xbox controller. That was part of the big Super Bowl commercial last year.
That was made by OT.
That was made by OP at Craig Hospital. So yeah. So she collaborated with our group, which is really exciting. So as we talked about before, Makers Making Changes in Canada, but it is in the US as well, and you can search by your community and actually find makers and their skills and connect with them, and then actually email and communicate with them through this website. So it's been really great. They do have somebody that reads all of your emails, which is how they realized I was trying to figure out how we could become a site, even though they didn't list that they were looking for one in the South. But they are extremely helpful. So you can request a build in several different locations, one of which is through the Request a Build site, another is through your profile, and finally you can do it through just seeing all of the devices and click Request a Build, and they'll connect you with a professional that can do that. If you don't have a professional that can build them in your area, they'll actually reach out to any one of their builders, and then the individual that's requesting the piece of equipment is the one that pays for the shipping and the device cost. And that's significantly different than a print-a-thon, which would be hosted at one central location, and then the networking site would actually help distribute it to the individuals with disability. So this is an example of where you can request a build or submit an idea. Z is actually part of Makers Making Change and is the one that is our site coordinator. So she works with all the sites in Canada and the US, and that's whose profile we're looking at. So if you're looking to get involved, I encourage you all to create profiles, list what skills you have so people can collaborate with you, whether or not they're individuals that have a 3D printer or these devices, so you can help them problem solve through issues that people are having. So yeah, do you guys have any questions on Makers Making Change? Yeah.
Is there a fee to be a site, or like, is it just, it's just a big, that's cool.
Yeah, there's not a fee, there is an expectation. There's not a minimal requirement if you're just an individual that's a professional coming on, like if Kelsey wanted to list herself as being familiar with 3D printing, she can just have a profile and she's not required to do any specific thing per year. She can just collaborate generically. If you're a chapter leader, you're required to do, or strongly encouraged to do, 2 print-a-thons or connecting events per year. And so that's the phase that Shepherd is currently in. We're in our promotional phase and networking phase.
Kristen, could you talk a little bit more about what it means to request a build? Does that mean sort of, I guess, printing something that's an existing file, or kind of like
it can be anything. Yeah. So if you have something that you want but it doesn't currently exist, you can literally just write up the profile and then they send it out to makers and people that are healthcare professionals that can help problem solve it. So it can be both. It can be something that currently exists or something that you wish did.
Is it international?
Mm-hmm. Yeah. At this time, it's primarily Canada and the U.S. I will say that they closed the number of US sites that they were allowing last year because they found the majority of the prints actually went to US citizens opposed to Canadian, even though it's a Canadian-based and Canadian-funded group. And that obviously is likely a reflection of the way that we provide assistive technology based on insurance and all sorts of things.
Mm-hmm.
So, yeah.
So you mentioned how long it takes to make these products.
Definitely.
How much does it cost?
Actually, that's listed on their site. So the whole low-tech kit, I believe, was listed for $27, and that's like the cost of the printing materials. It doesn't include what the cost of the time for that professional would be. It's just the cost of the materials that they suggest on their site too. Because depending on what you choose to do for like the density of the fill, that can change the print time and the cost of the device. So John, when I started talking to him, he made these much more dense, like in the fill, much differently than it's suggested online, which is why it took him longer to print than the kit was supposed to. So their kit it was listed as taking 5 hours to print, and it took him obviously longer because he made them much denser. And we don't get into that much detail in the next one, but we will kind of review the very basics of 3D printing. Does anyone want to get more food at this time? Stretch, get a coffee.
So our Zoom has it.
Okay.
Yeah, so we're at a 40-minute limit, so I think because we started a little bit
early. And we can email out, if we have the emails to them, another Zoom and just start one right now if you want.
Okay.
If you have them.
Yeah.
Okay. That's all good if you don't mind. I will defer to my expert.
So the joust that they had up there, what it costs, the joust, the quad joy, the quad stick, they're all in the range of about $1,000 to $1,500. And so this is a low, sorry, my mouth's a little broken. So this is a low cost option for it. So on Makers Making Change, we actually printed it in 2017. That's how long we've had it. So on Makers Making Change, when they first started, you could go on there and they had the list of all the electronics, all the pieces, and the files to print them. And so it Bluetooth connects, or it can connect via USB. It does need a power source, so you have to plug it into like a charger, and then you put your mouth on this and move it around, and the mouse will move around on the screen. So it's a low-cost mouth, and I think it was like $150 for all the parts and pieces of printing it. And everything was listed. Like you could click and say add to cart, all the components, the computer, everything, Bluetooth, all of it. And they give you instructions on how to purchase it and make it.
And this might be very obvious to state, but the part that's 3D printed is the red part. The rest of it are the pieces that you like snap together, and then there's some minor, not soldering. I always want to call it soldering. It's Thank you. Yeah, that's exactly what that's
so
here
like
for.
just like on here, the only thing in this kit that is actually 3D printed is these pieces right here. These two pieces are the only pieces that are actually 3D printed.
And this would be a small switch that you'd put together at like a build.
They call it raindrops, so it'd be a little switch like this. The other pieces are cords and the motor component, and these are purchased online. So they print these parts, and then they tell you exactly what you need to buy and where to buy them to put them all together.
So do you care if we pass around this one? We don't have to pass around the other one. Yeah.
Oh, we did.
Oh, you did? Okay.
We did.
Sounds great. Do you guys have any other questions before we get started? Cool.
That can hook up to you for the phone?
Computer. Phone. Computer phone, yeah. It's
Yeah.
USB.
So is it sip and pop too?
Yes, so it's sip and pop, yes.
And toggle?
Yeah, so if you want to see the instructions in the guide, I can pass those around.
Okay.
Yeah. And right now, during our last, because we have monthly chapter meetings where they have both you can pick one of two nights during the week, and they will have all of us come online and talk about the projects we're currently doing and the focus that they want us to maybe consider if we have someone that's really a go-getter out there. One of the focuses they have us considering as we network with people is focusing on mounts, because what they found is a lot of the devices are really great, but we don't have really great mounting options. So Adina has a mount that we have here in center, but that mount isn't 3D printed, and mounting can be extremely expensive and can be a real challenge for people. So, yeah. Cool.
I'm playing around with a lot of camera mounts now because they're less expensive. Camera mounts, yeah,
Yep.
because they're less expensive. They also play around with a lot of bicycle mounts and bicycle accessories because they're also less expensive.
Yeah, and the quick release options are really great. So. All right, so we're going to move into 3D printing basics. This could be a weekend workshop. I mean, it can be a lot of different things, which I have a survey, and then you guys can tell me what you want for the next one, and the people online, I'll email that out to them. So we'll get started with 3D printing. So I feel like a lot of people will ask, like, well, when did this all start? I feel like I woke up and then suddenly it's a huge deal. So this actually started in the 80s. This is, to me, very depressing, but it actually started in 1981 in Japan, and then around the same time in 1984 it occurred in France. And in both of these situations it was really similar, and it was researchers that published papers, had some ideas and demonstrated the capacity of this and how powerful the tool was, and had their funding denied. I know, so it just breaks my heart. Both of those individuals basically created a resin printer, the two from both Japan and France, and the individuals that were denied. The French party. They actually tried to get a patent on their own and tried to do their own, basically what we would call a crowdfunding now, and they just couldn't get it off the ground. They could see the potential, but just could not find the money to do it as part of their side hustle, really. So when you read about these groups, it's incredibly interesting, and they should be credited for the groundbreaking work they did. But unfortunately, the U.S. swooped in 1984. So this cracks me up. It was a furniture salesman who was frustrated with the time it took him to get custom-made parts. And he had done a lot of things with resin because he specialized in doing tabletops with resin. And what he realized is that he could use the UV lights and a traditional printer to actually print what he wanted to have custom made. So a lot of these things were like little knobs on things, some type of design emblem. And so he actually started using the UV lights in his workspace, his printer, and his computer to use photosensitivity to actually like fuse the resin or the materials. So he originally started doing this in 1984, and by 1986 he was able to acquire a patent. And he actually really did, Charles Hull found the first company that was able to turn a profit. He's still alive and kicking, and his company's doing great, and he's sitting pretty, to say the least. His printer type was really a resin type of printer. We'll go over, there's 9 different primary types on the market right now. But by the time we were hitting the 1990s, that's when additional forms of 3D printers came about, and they really exploded. So after he came out with his patent, other people really started going to town on trying to create additional ones. His company was really leading the way in this and figuring out other types of printers that could be created. By 2005, we have an individual that launched RepRap, which is an open source initiative to create 3D printers that could print itself, and that was really the goal of RepRap. So that really blew things open, because as we talked about the Makers Making Change, their presentation that they have us do, it's around the same time, obviously, that the Makers Making Change was coming to fruition because crowdsourcing became so big. And then we're putting CADs online. By 2008 through 2011, we have Darwin, which is a self-replicating printer which is released. And by 2011, I don't know what metric they use. I started reading it, but honestly did not find it very riveting, but whatever is considered mainstream, there's actually a metric they use, and at 2011 is when 3D printing actually hit whatever that metric is to be considered mainstream and no longer fringe. So it's not in your head, it did kind of explode overnight. There were a small subset of people trying to do this for a long time, but that just couldn't get it off the ground. You're going to hear 3D printing referred to a lot of different ways. Overall, it's additive manufacturing. And it can also be referred to as desktop manufacturing, rapid manufacturing. The one that cracks me up is rapid prototyping, on-demand manufacturing, and on-demand printed. Regardless of the type of printer, they have the same principle in mind, which is this quote at the bottom, which is the generic definition that you'll find for 3D printing. So it's the action or process of making a physical object from laying down layer by layer to create something that's 3D. It doesn't have to necessarily be laying down, and it can actually be building up, which is what we'll talk about. The original 3D printer was a resin printer, which was really built by rising up and using photosensitivity to kind of harden the resin as it was growing upward. The current 3D printers that most people are used to work by laying it down, which we'll get into now. These are the 9 types of 3D printers that are current, considered like readily available and used. We're not going to get into all of them because I don't have that kind of depth. And they're not going to necessarily see them for therapy. The most common type of printer you're going to see as a therapist and that you're going to see in healthcare is, from our standpoint, not necessarily people that generate like hearts and things like that. But what we're going to see, and most hospitals have chosen to use from a therapist perspective, is the fused deposition modeling. So this is really using that thermoplastic. The other type that we'll review today is resin, which is what I was referring to before. And this is the original type of printer that was developed in the 80s. So that fused deposition modeling, that one did not come around until that like the 90s mark when things were starting to explode. The original ones really were the 1 and 2. So stereolithography, that was the one that the individuals in Japan, in France, and then the original one Charles Hull came up with. All of those fell in that number 1 category. We'll talk about the pros and cons of both types. Any comments or questions? I feel like you know how to 3D print. Do you have any words of wisdom?
No, I just, yeah.
Okay. Okay. We'll rock on and then just interrupt if you have comments. Okay, so
This is resin, right?
This is resin, or pardon me, this isn't resin, this is fused deposition. And I have a really great picture that shows the difference in the 2 types and how you'd be able to tell. But yeah, we won't have you fall asleep by telling you the spoiler alert soon. So it was developed in the 1980s, so I guess I was wrong. But it was when we were exploding with Charles Hull's company. So he was part of that company that created it. It was popularized by that company, that's Charles Hull's company there on the second line. And basically, this is a picture on the bottom that we stole from the internet, and it's really demonstrating laying down layer on top of layer. Obviously, this is the emphasis really to demonstrate that this is an injector that's laying down the object and it sits on a bed, and that's really what you're supposed to focus on. This object here in the corner is really representing the fact that having the bed level is very important, because that can really screw up your prints, and I would say that's probably the main problem that hospitals have right now with 3D printing and why they struggle. So what cracks me up is this is just thermal plastics, right? Like, we're very familiar with how thermoplastics stick to one another, how quickly they can be manufactured and things of that nature. So if I'm walking into a patient's room and I need to make a resting hand splint, am I gonna wait how many hours to print with this, or am I gonna use a giant chunk of sand splint, right? So as a therapist, we can really appreciate how rapid prototyping can be because we've been doing it forever and a day. The thing to remember with fused deposition modeling is, because of the way it's laid down, there are small lines on this. So when we pass it around, you can actually see, when you tip it back and forth, the lines of how John McDaniel printed this, because that's how it was lying on the bed. So this one, if I can steal that from you, when he printed this, it was sitting like this. So when it lays down, you can actually see that those are the lines that come this way. Does that make sense? So yeah, I'll let you pass that around. And so when you actually look at a 3D printed object, you can kind of tell which printer printed it because you can see if it needed to be sanded, if there are lines, all sorts of things. I'll pass that one back around. Okay, so I think what really intimidates people about 3D printing is that there are a million printers on the market, and it's hard to tell what's happening. So this is not even all of the printers that are currently on the market. But if you think about what Makers Making Change talked about, opened or closed systems, these printers really fall in a divide of being opened or closed systems. So things like MakerBot, that Jennifer's school just got, is considered a closed system. So that device, you literally pull it out, she's gonna level the bed, she's gonna lace up her thermoplastic that she wants to use, and it's a closed system. The one that, I cannot not remember the name of the new name that CIDI uses, that one is one that is not a closed system. They can change how big their bars and their plate is to alter the way it prints. So all of these different types of printers, it's really whether or not you want to have an open or closed system. Do you want me to wake it up? You hit the, press, yeah, perfect.
They're not able to hear at the moment.
Oh, I'm sorry.
I was wondering if it was your mic.
It's all good. So regardless of the type of 3D printer you choose, whether it's open or closed source, whether it's any of those 9 printer types, we always have the same 6 steps that apply to printing. I did snippets of all the different types of common programs that go along with each of these steps. But these 6 steps are true regardless of the type of printer you use. So the first step is kind of optional. So when people talk about being able to put like somebody that broke their arm, take a picture of their hand and actually print a cast, they're talking about using this, which is an access to 3D modeling application or a 3D scanner. The one that's in this picture is a really low cost one that actually, that little handle here, you would turn it and then the phone will rotate around the object equally to take a video of it, and that information can be passed along to a virtual design or 3D printing model for printing. The more expensive that you're going to put into all these products, the higher the print quality or the higher the graphic quality. So kind of keep that in mind. This one on the left is very low cost. You can get ones that are much more expensive. The next one is the the virtual design or 3D modeling software. I would say the most common one, and I think popular, correct me if I'm wrong, is really Thingiverse. That's the one I tool around with the most. And if you go to Thingiverse, that's actually where all of these low-tech ones that Makers Making Change uses. So Makers Making Change will link to these other open source groups. From there, once you pick your design, you actually put it into another software program called a CAD, so a computer animated design software. And the point of these CADs are, you don't know the quality of this, the step 2, you don't know the quality of somebody's design product. Did they just scan something from a video game and put it in there? What's the structural integrity? I don't know. So on Tinkercad, you can actually fuse the pieces together, add extra structural supports to it, do it yourself. So on this one, because John McDaniel is so kind and so ambitious, what I didn't tell him is I got approval from our marketing department to put Shepherd's logo on everything. So as a host site, you can put logos on anything. So if GOTA decided to host a maker site, we could put GOTA's logo next to the Shepherd Center logo, and everything that GOTA prints through a GOTA networking event could have GOTA's symbol on it to promote us, you know? And you would do that through we would do that through Tinkercad. So some type of Autodesk or tinkering or CAD design software is how we put that emblem on. Next, more software programs. The next thing we have to do is actually take the model that we just made, and we have to make it in a format that the computer can actually print it out the way we need it. And what it prints is it prints in layers, right? So this next software is called a slicer. And a slicer works by doing just that. It lets you take the object and actually scan through the different layers to see if it has all the integrity it needs. So for a good example of this is, like, say this gear were hollow, but you wanted this gear to help turn your bike. If it's a hollow device, it's not going to have the structural integrity needed to do that. So in the slicer program, you can change the density. You can alter the way your printer prints it, because this is the last thing that you're doing to program how it prints. So this device, they tipped up on its side because when things print, they print onto the bottom of the bed, which this rendering here with the checkers, that's representing your printer bed. So if I put a flat object on the printer bed, when I have to pull that up later, it's printed to it. So it's like, it's a thermoplastic, it fused. Who's ever dropped, you know, a splint on the table, and then we were like, oh God, like, I'm gonna ruin like a $5,000 mat, like pull it up quickly. But the idea is if you tip something on its side when you 3D print, it's much easier to get off the printer. So you can actually alter the way the object prints. You can print it upside down, do things that are gonna improve the structural integrity.
Hairspray.
Yes, glue stick. Yes.
You spray the bed with hairspray.
Mm-hmm. Yeah.
With hairspray.
Yeah, it's hairspray. A purple glue stick is really,
Something that's flammable.
yeah, right, terrifying. And the reason why, right, is because we want it, yeah, you know, think about the way in which something dries, right? You want something that's going to help it dry and close up quickly, opposed to sitting down and fusing to your bed. And that's like a lot of people will actually put glass and clip the glass onto their bed and then level to the glass level. So that way you're not printing to your bed, because if you happen to ruin your bed by printing something inappropriately, you can just take the glass off and throw it away. So there's all these tricks of the trade that people use, but because all of this is open source, you have to kind of have someone to coach you through it. All right, the final 2 steps is really, I'm going to take that sliced software the way that I like it. I'm going to put it on something so that way my computer can read it. So this can be as simple as a thumb drive or as complex as Octoprint. So I could theoretically watch my print from like my cell phone while I'm at work, which is what John McDaniel does with his prints, which is just awesome. So cool. Yeah, and so if you go to Decatur Maker, I love that group. They are so kind. You can actually go online at Decatur Maker and you can watch a print that you started from home that's occurring at Decatur Maker. And the reason why people do that is because if your printer isn't working properly, you're gonna make spaghetti. You're gonna waste all this material.
I mean, I was just thinking,
Wake up in the morning
I
and
had an
spaghetti.
embroidery machine, and I was like, please don't do anything bad. You
Yeah.
Because I mean, you have to watch it.
Yep.
The machines are not infallible.
Yeah. So being able to watch it remotely, you can actually cancel the print if it's going haywire.
Stop it.
Yeah, you can cancel a print.
Wow.
Sorry about losing you guys, the digital people. And then finally, we're gonna see what it looks like to 3D print things, especially since I only have 10 minutes left. So bear with me. I tried to pick one that was quick and adorable. This is Baby Groot being printed. Baby Groot. Did you print it? Oh, that's hilarious.
Baby glue.
So this is an example of 3D printing occurring. That's the actual speed. So when we talk about rapid prototyping, rapid's a generic phrase. That's the thermoplastic filament that's being pushed through the printer top that is actually heating it up. There are all these other tricks of the trade, like creating a skirt, a boat, all these different things that you can do to make sure that the filament comes out the right way, but we're not going to get into that depth today.
A skirt, like clothing?
No, it's really just a way to make the thread go around an object, and so that way you know that you have the thread all at a consistent heat before starting the object. They call it a skirt, I don't know. So this is a good example, right? They broke Groot into 2 parts, so that way he could print more appropriately. Yeah, and so that's the other thing. So that's a great example. Adina just said that her Groot was in one shape when she printed it. This Groot, which might look the exact same, is printed in a totally different way because the way that they manipulated it in that Tinkercad and the other slicer software would have been different. So you can have, like this Groot, they're actually telling you the density that they did in the infill. So her Groot might be very light. This Groot might be very heavy. And some people, like if you're going to print something like, let's say, a weighted pencil, you might want to print it hollow so you can actually drop in weights and change the weights. So therapists have done things like that, or they'll drop like a mini vibrator that you can use like to turn on and off remotely into the objects. That way that they have that stimulation back. All sorts of ways to manipulate that. The options are really endless. Do you guys want me to power through resin printers in the last 5 minutes, or you want to talk about just the one type of printer we've talked about? Power through?
Talk about
The reason I'm saying is, we're gonna have to workshop, I hope so.
Yes, there's no shortage of information to cover though in a workshop too. Do you guys want to do it by the vote? Power through, raise your hands.
Go ahead. Go for it.
Only 2, 3.
I defer to you. What do you think would be
Yes.
best?
Okay, we'll power through. All right, the next type we're getting into is called resin printers. They work by curing a photopolymer material. So they work by using a liquid resin, which then we put a certain type of light on it and it fuses it as the device pulls upward. These two that we're focusing on use ultraviolet lasers, mirrors, or a type of projector that puts ultraviolet light on the object to then cure it as it goes. This has different types of challenges. I'll just tell you that much. So these are the 2 main types of resin printers that we highlighted before. So we've got stereolithic and digital light processing. I do not know why, and I did not dive into it enough, but some people call it dark light processing opposed to digital. They're the same type of printer. I don't know where the name split occurred. Just in case you come to the internet and find the word dark, this is the same type of printer. So the SLA is the original printing method that Charles Hull used. It's the same one that was actually talked about in both Japan and France. This is slower and it uses ultraviolet laser and mirrors to cure the resin as we go. The digital light processing is a newer method, it's faster, and it uses a projector to cure large areas of resin at one time. So we're talking a resin reservoir. What is important to note here is that resin printers produce superior prints compared to fused deposition modeling, and that's like non-debatable. They are far more detailed and far more elaborate than you can get with fused. Resin printers are made from a bottom-up for curing, which allows for fine detail and less post-process working. So when somebody prints something like this, or like let's say I was going to make a finger splint, when I pull this off the printer, I'm going to have to sand it down because all the layers are going to be rough. Depending on how thick I made my layers, the layers might be really rough, like I can cause skin damage. And as OTs, we know all about like wound care and skin concerns and pressure points. And these are the things that we're finding that individuals that might have their heart in the right place, but aren't networking through some place like Makers Making Change because they don't have that healthcare professional involved, they can actually make devices that cause more damage. And we're seeing this a lot in the O&P world. I think people are wising up, but it can be quite a challenge. I know we talked about this a lot when I visited Rachel last. Did you want to add anything? Yeah, people's heart are in the right spot, but they just don't have the healthcare background. So you're a powerful force, and get into 3D printing, or at least collaborate with somebody doing it, because we have a lot to offer. I think therapists, we tend to shy away from this kind of thing. All right.
Basically led people to OTs because it's like somebody that actually was, fabricating a splint. And these guys had this great idea, and they printed it out, and it looks all great. And they brought it and wanted our opinion. And the first question they said was, well, "Have you worked with an OT before?" And they just looked at me, and it was just, it was well intended, but they had no thoughts of skin integrity and the medical aspect of it, and it just opened up a conversation. They were just excited that they printed something.
I know.
And I was like,
yeah, it's really crazy. We get lots of emails to Shepherd, just the Shepherd info, and I had 2 this week that were just people wanting to learn about, like, I want to do this professionally, some being really niche, and then do you have people that do that at your job, or can I be the one to bring it there? And I'm like, this is OT, but people are like,
do that all the time.
New profession, who dis? Like nobody, I feel like we need to really promote ourselves and make sure that we're on the forefront of these types of things, because engineering, bioengineering, things that you'd think that they would know about us, they really don't. They just think of PTs, they think it's not functionally applicable. We have skin in the game. So what do we talk about? The 6 steps of printing are the same no matter which printers we're talking about. Resin printers are the same. The only thing that's different is that final step, the step 6. She's gonna pass around, oh, you got your baby. Your baby Groot's big. Oh, and
one piece and
yes.
painted, it was white.
Do you have any of the controller switches that don't have the supports pulled off?
Yes, I do.
Perfect, okay. So before I hit the play to this, when we do diffuse, remember how we talked about how resin printers are always gonna be superior to fused modeling? So all of the things, and that's not to say that there's not a place for both, but all of the switches that Adina has are done through fusion. And because of that, obviously when you're creating something, you're gonna need to add a support, or the device is just gonna fall through on itself because it's a thermoplastic, right? So it's not hardened immediately, or else the layers won't stick. It's just like if you wanted to fuse 2 splints together, it's not gonna work if they're not hot. Yeah. So they print supports into it, which then are less structurally, Yeah, less structural integrity, so Adina can actually snap off that support in the middle to then allow it to both print properly and then for it to have the shape she wants. But that's a good example of the seam too.
See it.
This is actually one of the, this is a maker, but this is a 3-piece. And it fits into, I think it was a promobile wheelchair, into the holes, so that it can be a cup holder and a tray.
Yeah. Cool. Any few questions before we move into resin? There's a little quiz at the end. It's very low key. Good. Okay, so this is just a time lapse. Same type of thing of how a resin printer works. Because I feel like I can explain it all day, but it doesn't really help unless you see it. So it's pulling up from a resin reservoir, pulling up, and then the light is hitting each layer as it pulls up. So it looks very continuous, very smooth. But as you can see, this printer, it's a completely closed system, right? Like we're restricted by the size of the resin reservoir. We're restricted by the size of the square, the way that we filter light, right? The reason why this printer is a different color is because we have to filter out the UV lights we don't want. We have to regulate the type of UV light and the intensity it is applied to an object. A lot of people that are trying to make their own resin printers are coming back home from work and they're finding that their resin has hardened into the reservoir. You want to talk about an expensive mistake? They've just made like a very expensive square like, because the light in the room naturally printed their object for them. When you talk to different maker spaces, it's a really hot topic on how they approach resin printing. Decatur makers feel so strongly about it at this time, they actually don't allow resin printing because of the off gases. Whereas if you go to Free Space, because they love detail and they love fine work, Free Space loves resin printers and they've got multiple you can play with. When I've talked to other model systems, some of them have not actually gone into resin printing because we don't know the long-term effects of the resin itself. Theoretically, it should be a carcinogen, but we don't know the type of exposure. Like, there's no long-term studies to demonstrate that huffing it is bad, but like logically, you shouldn't be in an enclosed room with resin printers. But how much exposure to resin printing fumes are safe, how much exposure to skin contact, all of those things haven't really been studied yet, which is part of the reason why therapists in general and healthcare workers are moving toward fusion, which is what our objects are here. Which there's debate among which type of thermoplastic to use too. So this is a great example. So I love this photo. I apologize if you can't see it very well, but this object, printed by resin. This product, they're supposed to be jokers, I guess. This guy is printed with fusion. So this guy, you can see all of his little lines. He's kind of like, I don't know what, we're getting pretty picky, I guess, but he's less smooth. He needed some like smoothing out. There are different chemicals you can dip him in to help get rid of like the little lines that you see in these types of prints. Whereas the resin guy, he came out like looking dandy, and he was likely printed upside down, right? Like this was probably his base, that was the top of him, and he was pulled up, and so this was the last top. His little hair was probably the last thing printed. And he's much smoother, much clearer. So determining whether you want a resin or a fused deposition modeling printer really depends on a few things. The goal of printing. If I'm a jewelry maker, I'm picking resin. If I'm maybe printing mass objects like this, I'm picking DFM, FDM. I still can't get it right. Anyhow, we're going to want to look at materials. So resin printers, the resin can be much more expensive than just a really cheap thermoplastic, but you can get really expensive types of thermoplastic to print from too. So I really want to pick my material and look into the components of that. Next is waste disposal. Part of the reason why Decatur makers right now isn't using resin is because there should not be really a safe way of disposing of it. So what do you do with your resin that's left over? A lot of people do a lot of different things with it. Some people mix it with powder, some people harden it, or just print a square and throw it away. I don't know. So how you want to dispose of your waste. Now, if you screw up a printer that's top down, this type of printer, you end up with spaghetti. It's a waste too, but theoretically less of a problem.
Kristen, is this thing supposed to come off on this?
That's a good question for Adina.
If not, I'll be writing a check.
It's okay. I can't see it from that far, but it's probably okay.
The next would be cost. So resin printers tend to be much more expensive than FDM printers. Durability, and that really varies on whatever type of printer you have. Resolution and detailing, we talked about resin in much more detail than the other one. And then finally, the printing environment. So do I have only a very small room? Maybe I don't want to buy a resin. Okay. So we kind of talked about that in general, but do you guys remember how long 3D printing's been around?
Since the 80s.
Yes, you guys are all so awake. I'm so proud. When I made this slide, I was like, in case people fall asleep. Do you guys remember what FDM stands for? Yay! Yes. She's so quiet.
Fused deposition, what?
Modeling.
Modeling.
Fused deposition modeling. And what are resin printers?
Stereo.
Good job. Yeah, that's one. Yeah. Yeah. And the other word that you'll see is dark online, dark or digital. Why, I don't know. I didn't read enough into it. And then which one would you guys choose for the type of practice you have? Yeah. And I mean, you could theoretically choose resin as well. Just there are some people, they get, yeah, right. Some people, they, you know, they really love fusion and they really love resin and they don't want to get away from the detailing. So. Yeah, so maybe if you're a hand therapist and you need a lot of fine motor objects, maybe you'd choose resin. I don't know. Any questions? You guys are so great.
How much waste does it, does it generate? Is it minimal?
I'll let the one that owns one answer that.
What do you mean by waste?
Well, like you said, extra resin, extra.
So we don't, I mean, if it turns into spaghetti,
Yeah, if you can.
it turns into spaghetti. That's the only waste that you have. You're not going, or the supports are the waste. But you do have to keep it, it does dry out, like the filament dries out. So you do have to keep, you know, make sure it's put in a bag if you're not using it, because that's a mistake a lot of people use is they just leave the roll just like you would leave Velcro rolls out, but you can't, you have to keep it inside of a bag. If anybody has
the stuff.
Yep, that tube that you saw rotating at the top, the stuff.
If anybody has Micro Center by your house, Micro Center has awesome 3D printing areas. You can go and like look at the actual materials and look at the different printers.
There's one right behind Jimmy John's by Tech Campus. So if you're by
There's
Tech.
one in East Cobb, right off Delk Road. There's one in Duluth. So yeah.
Yeah. References and resources. So obviously I borrowed generously from a lot of different websites for images, which is not kosher, but for this I did list all of them. There is some research done. There is a chapter in the most recent Umfred, which I know a lot of OT and PT schools use. Full disclosure, I wrote it, but it is based on literature that is out. This is also an example of the Makers Making Change site, so I didn't know how far into it we'd get. I know we're a little over, but this is just an example of their actual print-a-thon. I'm just gonna, if it'll let me. I can't mute because of the thing over it, but basically they're just showing you how they run a print-a-thon. They have, if anyone's going to AOTA, Tufts University is actually hosting a make-a-thon Wednesday night. So if you're there for a pre-conference, you could pay the $75. Oh, pardon me, it's free if you're a student, but it's more if you're like a community member wanting to attend, and you can actually see how a print-a-thon runs. Now obviously Shepherd will be facilitating some of these in the future, so if you have a printer or a will to participate, fill out the survey for me, that'd be really helpful, put your name on it. I have it digitally as well that I'll email out to all the virtual participants. But yeah, I know we ran a little over, I apologize. Thank you for having me. Yeah, do you guys have any questions or you good? Can somebody break the ice and sign Stan's frame, please? Stan had a family emergency, so he wasn't able to make it tonight. But we're partying in his honor next Friday. Oh yeah, that's right.
Any questions online before we close out?
I will post the videos and everything online, guys, so I apologize that we
Sorry for the
lost you.
connection error.